In this video, we'll balance the net ionic equation for FeSO4 plus KOH. We have iron 2 sulfate plus potassium hydroxide. So the first thing we do with net ionic equations, we balance the molecular equation. This is the molecular equation. I can see that I have 1 potassium here and 2 here. So I'm going to put a 2 in front of this potassium hydroxide. Now I have 2 potassiums. Those are balanced, 2 hydroxide ions. But I have 2 hydroxide ions here and then 1 iron on each side. This is the balanced molecular equation. Next, we'll write the state for each substance. So sulfates in general are very soluble if you know your solubility rules. So we're going to put an AQ. This will be aqueous. And then potassium hydroxide. Hydroxides in general are insoluble, but group 1 hydroxides like potassium hydroxide, sodium hydroxide, they're soluble. So this will be AQ. In fact, potassium hydroxide is considered a strong base, so it breaks apart, dissociates into its ions completely. But iron hydroxide, iron's not in group 1, iron hydroxide is insoluble. So because of that, we'll put an S here. It won't dissolve. These two will react. It'll produce this iron 2 hydroxide, but it won't dissolve. It'll be a solid. It'll fall to the bottom of the test tube as a precipitate. So we have this precipitation taking place here. Then we have potassium sulfate, put an AQ after that. Now we can split the strong electrolytes into ions, and that'll give us the complete ionic equation. Iron's a transition metal. We don't know its charge, but the sulfate ion, the whole thing, 2 minus. Good one to remember. So iron 2 plus. So we have the iron 2 ion, Fe2 plus. I won't write the states. Let's write those at the end. And then I have the sulfate ion, SO4 2 minus. Potassium group 1, that's 1 plus, and the whole hydroxide, 1 minus. So we have 2 potassium ions, 2K plus, and we have 2 of these hydroxide ions. And these are the reactants in our net ionic equation. For the products, we don't split solids apart, so we're just going to write that as FeOH2, that iron 2 hydroxide. Then we said positive and then 2 minus. So we have 2 potassium ions again, and we have the sulfate ion, also like we have in the reactants. So this is the complete ionic equation. Now we cross out spectator ions. So in the reactants, I see 2 potassium ions here, and in the products, cross those out. Those are spectator ions. And I have a sulfate ion here in the reactants, again in the products. Cross those out, spectator ions. What's left? That's the net ionic equation for FeSO4 plus KOH. I'll clean this up and write the states, and we'll have our net ionic equation. So this is the balanced net ionic equation for this iron 2 sulfate plus potassium hydroxide. You'll see charge is balanced. We have 2 plus here, 2 times 1 minus, that's 2 minus. So that adds up to 0. This is neutral, net charge 0. And if you count the atoms up, they're balanced as well. This is Dr. B with the balanced net ionic equation for FeSO4 plus KOH. Thanks for watching.